the arrow of time. Why does time only flow in one direction? Have you ever wondered why we can remember the past but not the future? Or why things seem to age and break down over time? These questions touch on one of the most fundamental mysteries of the universe, the arrow of time. Time appears to have a relentless, irreversible direction. We experience it as a constant flow from past to present to future. But why is this the case? Why can't time flow backwards or in multiple directions? To understand this phenomenon, we need to delve into some fascinating concepts in physics and philosophy. Let's explore the arrow of time and the theories that attempt to explain its unidirectional nature. The concept of entropy plays a crucial role in our understanding of time's direction. Entropy is a measure of disorder or randomness in a system. According to the second law of thermodynamics, the total entropy of an isolated system always increases over time. This means that, left to their own devices, things tend to become more disordered and chaotic. A sandcastle on the beach will eventually crumble, but we never see scattered sand spontaneously form into a castle. This increase in entropy gives time its apparent direction. But why does entropy always increase? The answer lies in probability. There are simply many more ways for things to be disordered than ordered. If you shuffle a deck of cards, it's highly unlikely you'll end up with all the suits perfectly arranged. The same principle applies on a cosmic scale. The laws of thermodynamics provide further insight into the arrow of time. The first law states that energy cannot be created or destroyed, only converted from one form to another. The second law, as we've seen, deals with entropy. The third law states that it's impossible to reach absolute zero temperature. These laws help explain why certain processes seem to only happen in one direction. We can turn an egg into an omelet, but we can't unscramble an omelet back into an egg. The energy and matter are still there, but they've been irreversibly rearranged into a higher entropy state. Some scientists have proposed that the arrow of time is linked to the expansion of the universe. As the universe expands, it moves from a more ordered state to a less ordered one. This cosmic arrow of time could be driving the direction we experience in our daily lives. Others suggest that time's direction is related to quantum mechanics and the collapse of wave functions. When we observe a quantum system, it changes from a superposition of states to a definite state. This irreversible process could be contributing to time's apparent direction. The concept of time's arrow also raises intriguing questions about the nature of causality. We generally assume that causes precede effects, but if time could flow backwards, could effects precede causes? This mind-bending possibility challenges our fundamental understanding of reality. Some physicists have proposed that time might not have a direction at all on the most fundamental level. Instead, our perception of time's flow could be an emergent property, arising from the interactions of countless particles and the increase in entropy. The arrow of time has profound implications for the possibility of time travel. While traveling to the future might be theoretically possible by moving at extremely high speeds, traveling to the past presents numerous paradoxes and challenges our understanding of causality. If we could travel to the past, we might be able to decrease entropy locally. But this would violate the second law of thermodynamics. Grandfather paradox also arises. What if you traveled back in time and prevented your own birth? These puzzles suggest that backwards time travel might be fundamentally impossible. Our perception of time's direction also shapes our understanding of memory and consciousness. We remember the past, but not the future, and our sense of self seems to flow along with time. Some philosophers argue that this psychological arrow of time is fundamental to our experience of reality. The arrow of time also has implications for the fate of the universe. If entropy continues to increase indefinitely, we might be heading towards a heat death where all energy is evenly distributed and no more work can be done. This gloomy scenario is one possible end state for our universe. However, some theories suggest that the universe might undergo cycles of expansion and contraction, potentially resetting the arrow of time with each new cycle. Others propose that our universe might be just one of many in a vast multiverse, each with its own local arrow of time. Understanding the arrow of time is not just a matter of abstract physics. It touches on deep philosophical questions about the nature of reality, causality, and our place in the universe. Why does the past seem fixed, while the future seems open to possibility? Is free will compatible with a unidirectional flow of time? As we continue to probe these mysteries, we're reminded of how much we still have to learn about the fundamental nature of our universe. The arrow of time remains one of the most profound and perplexing aspects of our reality. It's challenging our intuitions and pushing the boundaries of our understanding. From the quantum realm to the cosmic scale, from the laws of thermodynamics to the nature of consciousness. The arrow of time weaves through every aspect of our existence, shapes our experiences, our memories, and our very sense of being. As we look to the future, ongoing research in physics, philosophy, and cosmology continues to shed new light on this ancient mystery. Perhaps one day we'll fully understand why time flows as it does, unlocking new insights into the nature of reality itself. Until then, we can marvel at the profound implications of time's unidirectional flow and appreciate how it shapes the rich tapestry of our universe. The arrow of time reminds us of the precious, irreversible nature of each moment, urging us to make the most of the time we have. Like, share, and subscribe to Infinitoinial